This lesson is going to look at relations, functions, and one-to-one functions. So just starting with a couple of definitions, a relation is any correspondence between two sets, usually referred to as the domain and range. That can be given in a mapping form, like this first diagram here, in a set of points, in an equation, or in a graph. So basically in mathematics, everything is a relation. Every graph you see, every set of points you see is considered a relation. More specifically than a relation is a function is a relation in which each element of the domain is paired with exactly one element of the range. So you can see in the mapping here we have 1 going to 2, 3 going to 2. They can go to the same number, you just can't have two arrows coming out from any given number in the first set. If you look at the ordered pairs, if you look just at the x values, you just need to check and make sure there's no repetition. More specific then, a function is considered a one-to-one function, and this is a function such that each element of the range is paired with exactly one element of the domain. So in this case with the mappings, we can have only one arrow coming out of every number, and over on the other side we can only have one arrow going into every number. If we're looking at the ordered pairs, we have to look at the x coordinates to make sure there's no repetition, which tells us that it's a function. And then we also have to look at the y values and make sure there's no repetition in the y values. So if there's no repetition in either, then we can say that that's a one-to-one function. When we're dealing with mappings or tables, every mapping is a relation, so every table is a relation. If there's no repeating values in the x coordinates, then it's a function. So this example right here would be not a function because there's repetition in the x values. Since it's not a function, it can't be a one-to-one function. If it was a function, then to determine if it was one-to-one, we would test the y values and look for repetition in the y values. When we're looking at a graph, again, every graph is a relation. If we want to test to see if a graph is a function, we're going to use the vertical line test. You should remember the vertical line test from Algebra 2. Remember the vertical line test says we're going to take a vertical line and we're going to pass it across the function. And what we're looking for is that in no specific place can that vertical line intersect the graph in more than one point. So since as I pass this line all the way across this graph, there's no intersection of more than one point, then we know this is a function because it passes the vertical line test. So we would say this graph passes the vertical line test, therefore it's a function. Since it's a function, we're going to test to see if it's a one-to-one function, and for this we're going to use the horizontal line test, which is very similar to the vertical line test, except we use a horizontal line. So you can see at all of these spots here, we are intersecting this graph in more than one spot, so we fail the horizontal line test, therefore this graph is not one-to-one. Finally, we want to look at relations and functions with equations. So every equation is a relation. In order to determine if it is a function, we're going to look at the equation in y equals form or function notation, which is the f of x form. And we want to look to see if that is a unique equation. By a unique equation, we mean that no matter what value we put in for x, we can only get one value out for y. So in this first example here, we have y equals x plus or minus 2, which really means y equals x plus 2 or y equals x minus 2. So then if we plug in x equals 1, we could get y equals 3 or y equals negative 1. So this equation gives us the 0.13 and the 0.1 negative 1. So for the same x value, we're getting two different y values. So this tells us that this is not unique, and therefore this is not a function. We will not look at a situation where you have to tell if a function is one-to-one from the equation. So you just need, from the equation, we just need to be able to determine is it a function or not.